Hello, dear software developers. Here, a brief about fundamentals of computing. It accepts data, saves, executes, and provides the output. Here, what is a computer? What? A machine that can carry out any computational task. Is it really? Yes, it is formally proven that a computer, given sufficient memory and time, can carry out any computational task. If it's, then how? For this, we need to look inside a typical computer. So here you can see inside a PC, power supply and expansion slots, 5.25 drive base and 3.5 drive base. Here you can see the image. And now inside motherboard, back panel connectors, expansion cards in PCI and PCLE slots, storage drive connectors here top, and memory in memory slots, and here, and CPU in CPU socket. Here you can see the fan which cools the CPU, and here you can see the motherboard inside parts. Now let's look at functional units. Here there is a bus, and here is the CPU inside which there is ALU, arithmetic logic unit, and other is control unit. And here next there is memory where data gets stored, and next hard disk, and the next one is input devices like keyboard, CD, and many more, and the other side output devices like monitor, printer, and etc. Here you can see the CPU full form and memory, storage area quickly accessible from CPU, hard disk not so quickly accessible. So let's know about binary format. In a computer, everything is stored in binary format, a sequence of zeros and 1. The component of computer only understands binary format. For example, number 4 is stored as 0 0 0 0 0 1 0 0, and 1 is stored as 0 0 0 0 0 0 0 1, and many more. Execution in a computer. To begin with, all data and commands related to computation. Here you can see commands are brought into CPU through the bus as shown in previous slides. So here each command is executed inside CPU in the following way. If the command requires data, it is brought from memory to CPU, and the command is executed, and it may be stored present in the CPU to memory. Thus, a program is a collection of commands. Here is a small program 001, read memory location as 001, and this format reads memory location as 010, and this one adds two numbers read, and 001 gets stored in the memory location. Here is the execution part. Here the num1 location and num2 location, and here it shows in this way. Step 1, 001, it brings to CPU, and it gets stored in memory location 001 to CPU. And step 2, execution of 001 in control unit. Here you can see it's showing the first position. It brings data to location 1 in CPU. It shows in the control unit the output. And step 3, it brings 010 to CPU, and it shows in the memory location 010 to CPU. And step 4, it executes 010 in control unit. It brings data stored in location 2 num1 to CPU. It shows in location 2 this number. And step 5, it brings 000 location to CPU, where the two stored numbers gets add. After adding, it shows this way. Step 6, execution of the above number in control unit. The two added numbers get stored inside CPU using ALU. Here you can see the addition of two numbers as stored in this way. Step 7, it brings 001 to CPU, where the stored number in ALU gets to memory location 001. Here you can see it's shown in this format. And step 8, it executes 001 in control unit. The data gets stored in ALU num5 in location 1. Thus, now let's know assembly language. It's very difficult for us to understand binary language, which is called machine language. This is the only language computer understands. To make it more readable, assembly language is introduced. Here you can see it is addressed by names. Naming locations in example program. Here is the control unit, num1, num2. Here you can clearly see, for example, a program in assembly language 001 move num1 r1 010 move num2 r2 000 add r1 r2 001 move r1 num1. Here it is briefly explained what they signify and mean to the assembly language. Now, what are assemblers? An assembly language eventually must be translated to machine language to understand. An assembler does this job. It maps the corresponding. And now, what is IO? For example, it shows how to add already present two numbers in memory. This is the job of another program called operating system, which is called as OS. Let's know what is OS. So, OS picks the input given by the user and stores in appropriate location. It picks the computation from memory and displays to the user. It does many other housekeeping jobs that make the interaction of user with the computer easy. Examples of OS are Linux, Windows, Mac OS. For a better language, it's very difficult to write large language in assembly language. So, in modern generation, prominent ones are COBOL, Fortran, Pascal, and C. These are also called high-level programming language. In past days, assembly and machine language are called low-level programming language. So, here is a programming in C, adding two numbers in C. Here is the skeleton of C language. Here it is displayed. And here, int main denotes the beginning and end of the program, and int num1 num2 names of memory location, and num1 gets initiated, num2 gets initiated, and num1 plus num2 it adds two numbers. Thus printf writes the number on the monitor, and return 0 tells the OS the program gets executed successfully. Now we have to compile our C program. A C compiler translates a C program to machine language. There are many C compilers, but here we use clang for our C program compilation. Now let's see how to debug a C program. To debug a C program, follow the steps. You can use the debugging taskbar. Now click on Run and Debug. Here it shows as above. Here at first it had assigned some numbers to A and B. Here this button is continue, step over, step into, step out, restart and stop. Here if you click on step over, it changes the input of A as 6. Again step over, it changes the input of B as 4. And step over, C is equals to A plus B. It shows the output as C equal to 24. So this is how you can debug your C program. Here are the different stages of compilation in C-lang compiler. In compiling, our product.c is our source file. The file with extension .bc is LLVM bitcode file, which is low-level virtual machine, and the file with product.o extension object file, and the file with .s extension product.s having assembly code, which is shown above, and product.o file, and the file with extension.i, which is called preprocessor file. So this is how clang compiler works.